Welcome to PhyzQuest. So this is the CSIR NET December 2019 Part C, question number 23. The question is, let x cap and p cap denote the position and momentum operator obeying the commutation relation x cap p cap is equal to IH cross. Now if the state x denotes an eigenstate of x cap corresponding to the eigenvalue x, then e to the power I a p cap by h cross x, whether it's an eigenstate of x cap corresponding to certain eigenvalues or not. Those are the options, related options are given, and we need to choose the correct option. So let's get started. So this question comes from the section quantum mechanics, and the concept involved here is commutation relation. So here the question is based on the relation between position and the momentum operator, that is the commutation relationship is x cap p cap is equal to IH cross, which is given in the question. Now as per the commutation relation algebra, there are some other commutation relation associated with the position and momentum operator, that is the commutation relationship between their function. So when we consider the commutation relation between the position operator and a function of momentum operator, it will be, suppose if you have a function of momentum operator, that is fp cap. So in that scenario, the commutation relation between x and fp cap will be IH cross del f by del p. Similarly, the commutation relation between the momentum operator and a function of position operator, in that scenario it will be p cap and fx cap will be equal to minus IH cross del f by del x. So these are the two relationships which will be useful in solving this problem. Now in the question we are given that when an operator x cap is operated on state x, it gives the eigenvalue x. Now the question is, here we are given the state e to the power ia p cap by h cross x cap, whether it's an eigenstate of x or not. So that's we need to find out. So let's get started. Now what we need to do here is, we need to use the commutation relationship between x cap and e to the power ia p cap by h cross to solve this problem. So as per this formula, the commutation relation between x cap e to the power ia p cap by h cross will be IH cross del by del p e to the power ia p cap by h cross. This is as per the formula we have discussed in the previous slide. So this will be, when you differentiate it, this will be equal to IH cross IA divided by h cross e to the power ia p cap by h cross. So switch upon solving will give you minus a e to the power ia p cap by h cross. So this is as for the formula of the commutation relationship of function of commutation relationship between position and a function of momentum operator. Now when we want to write it, actually expand it in terms of a commutation relationship form, see, as per commutation relationship expanded form, the commutation relationship between a and b will be ab minus ba. So if you want to write down the same commutation relationship between x cap and e to the power ia p cap by h cross, it will be equal to x cap e to the power ia p cap by h cross minus e to the power ia p cap by h cross x cap. Now if you, so again our point of concern is to find out whether the eigenstate x is an eigenstate of the operator, this one, this term x cap e to the power ia p cap by h cross. So this we can write as x cap e to the power ia p cap by h cross. This will be equal to the commutation relationship between x cap e to the power ia p cap by h cross plus e to the power ia p cap by h cross x cap. Now when we operate both the side with the eigenstate x, so it will become x cap e to the power ia p cap by h cross with operated with eigenstate x, which is operated with the commutation relationship between them, plus e to the power ia p cap by h cross x cap x. Now instead of this formula, this term, we can use this relationship we have already calculated. So if we put that here, this will be minus a e to the power ia p cap by h cross x, plus here this term we have already given that when x cap is operated on x, this gives the eigenvalue x. So this will be equal to plus e to the power ia p cap by h cross x with the operator x. Now ultimately when we finally write it down, both the terms have e to the power ia p cap by h cross x. So ultimately the final term will be x minus a e to the power ia p cap by h cross x. So if you look carefully here, x cap is operated on e to the power ia p cap by h cross x, and we are getting an eigenvalue equation where eigenvalue is x minus a, and again here we have the same term as we are here. So as you can see, we have got an eigenvalue relationship when operated with the operator x cap, but the eigenstate is different. Instead of x, we have operated here in e to the power ia p cap by h cross x. So here the eigenstate is this term, and the eigenvalue we have got is x minus a, which was the question here. Now let's check the option. Now if you check the option, you can see that as the question says, x denotes the eigenstate of x. So then e to the power ia p cap by h cross x is, here if you read the terms, option C, an eigenstate x cap corresponding to the eigenvalue x minus a. So this is the correct option here.